because mine's already started. So today we're going to work on finding inverses of functions, and I gave you a warm-up problem. So this is the first problem you're going to try in your notes on your own. But Saka, you actually said something. What do I do in order to find inverse? Switch the x and the y. So which one's y here? F of x. So I'm going to switch this to x and this to y. And I need to solve for y. So I'm going to divide by 8. So I get y equals x over 8. Sure. Let's put the -1. That means inverse, right? That's our little statement to help us to remember inverse. How many of you remember that from way earlier in your math career? Good. So it's been a while, but you may remember that. How do I verify my answers or functions? I'm sorry, how do I verify my answer is correct? Does anybody remember that from algebra 2? I what? I don't plug in a number. That was a good idea, though. Okay. Here's how I do that. I need to check f of f inverse of x with f inverse of f of x. And what do they both have to equal? The same thing. Do you know what that thing is? It's not 0, it's actually x. And this is what you did on last night's homework, right? Okay, so I'm going to take f inverse, which is x over 8, and I'm going to plug it into this equation. So I have 8 times 1/8x. What happens to the 8 and the 1/8? They cancel. What are you left with? Good. How about you go ahead and try this one instead? You try the bottom one. How'd we do? Good? You lost. So you take the f function. What's the f function? 8x, right here, right? F function. And I plug it into the inverse function. What's the inverse function? Okay, so instead of x over 8, I'm going to write 8x over, which equals, so it's the practice of last night's work. How many of you now kind of vaguely remember doing that slightly in algebra 2? All right. I mean, it may have been a while, but do you remember doing the composite function? Yeah, we did that last night on the homework, right? And that's why it's so important to make sure you understand that. All right. So we're going to graph these two, but we're not going to make a table of values. You know what we're going to do? We're going to use our transformation. And this is the only one you're graphing, by the way. That's why I'm not going to make you have a full sheet of graph paper. But remember, if you do want to paste a graph in, I've got graph paper here. So we're going to record these, we're going to graph these two graphs. Let's start with x squared plus 1. What is the parent function? X squared. What does x squared look like? Looks like a parabola, right? Now, what do you know about this parabola? How is it shifting? Up 1. So where's it going to start? 0, 1. It's actually going to start right here. And it's going to make a U. Now, real quick, what's 1 squared? 1. So I'm actually going to go over 1 up 1. What's 2 squared? 1. So I'm going to go over 2 and up 1, 2, 3, 4. Some of you may remember that from algebra 2, where all I did was use the parent function to help me to know how far over, how far off. There's my x squared graph. That was pretty simple to graph without a calculator even, wasn't it? Okay. The square root of x minus 1. What's the parent function? Square root of x. Okay, what does that graph look like? You can draw it in the air if you know what it looks like. Yeah. Okay. It's just a little curved line, right? So it's going to look like this. Where does this point originally start on that graph? Normally 0, 0, but now it's got to move which way? Right one. Notice it's inside the parentheses, or inside the square root sign. Okay, so inside it's got to move to the right one. What's the square root of 1? So if I go over 1, I can go up 1. So I asked you what's the square root of 1, and you said 1. What other square root can you do in your head? You can do the square root of 4 in your head. So from this point, I'm going to go over 4. And what is the square root of 4? So I'm going to go up 2 and draw in my graph. Well, I went from the original, from the point that I started with. What line would this actually be reflected over? Well, what line could I draw into this? If I drew a blue line, because I changed the color to blue, what line would it be? Anybody know? Is it reflected over this axis? If I reflect this over here, it equals this exactly. If I reflect it over the y-axis, does it make it? You mean it's both the x and the y? How do I say that? Wouldn't it be like? Wouldn't it, So you're actually right with with both, but it's actually a slanted line of y equals x. Okay? What's the y-intercept on that line? What's the y-intercept on y equals x? Not 1. What? 0. X plus 0. So it's 0, 0. What's the slope now? What's the slope? Now that's 1. So I'm going to go up 1 over 1. And if I draw that line in, do you see how now that's reflected right over that? So the reflected line for a function and its inverse is y equals x. This is the line the graph would be reflected over. Okay? It'll always be that. 100% of the time. What test do I use to determine if a graph is a function? Just this. Vertical line test. That's a key thing right there. Vertical line test. But how do I know if the graph has an inverse function? How do I know if it has an inverse function? Horizontal. Line test. Now, some of you that took Algebra 2 last year or the year before will remember me during a quiz saying hi to you constantly. Hi, 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 because horizontal checks for inverse. Horizontal checks for inverse. Hi. We kind of go together to help you out. Horizontal goes with inverse. So now let's find the inverse of something. We're going to find the inverse of f of x equals x to the 4th minus 10. And then we're going to determine if it's a function. So, one more time, Ryan. What do I need to do first? Switch the x and the y. So I'll make this x equals y to the 4th minus 10. I'd like everybody to take a minute and solve that. So, tell me, Logan, tell me what I would do first. Yes. Perfect. I just had your tongue tied there. Sorry about that. Pick somebody. Trevor, what do I do next? I take the fourth root of each side. So here's my answer. Is that my answer? Is it? Something's missing. What? It's missing a plus and a minus. Why is it missing the plus and a minus? Because I took the fourth root. I took an even root. Anytime you put an even root somewhere, you get a plus or a minus. Odd only has one root. So even, you always get two. A plus and a minus. Yes. Like if I was solving this, y equals x squared. Let me go through that real quick. I'll switch x and y. I'll take this square root. Uh-oh, I put an even root. What do I have to put in front of it? Plus or minus. Okay? You have to remember the plus or minus if you put an even root. Now, if this was the original problem, do I need to put a plus or a minus in front of there? No, because it was the square root was there already. I didn't put it there, right? Here, I had to take the square root. I put this square root sign in. Was it in the original problem? No, I put it in. I introduced it. It gets the plus or minus. Okay? Any questions?
How would you solve that last problem, though?
Okay, so you want to do square root of x minus 1
Yeah.
equals what? Switch x and y. So I get y minus 1 equals x. How do I get rid of a square root? Square it. So I get y minus 1 equals x squared plus 1. So I get y equals x squared plus 1. Okay? So let's review this one more time. When you take an even root, what must you put in front of it? Plus or minus. What if it's an odd root? Nothing. Or if you'd like, if you want to put something, you can put a plus. But you don't get to put the minus. Does that make sense? Justin says yes. All right. You have the last 20 minutes to work on that essential work. Please attempt every single problem.